understand.
Okay, sorry, it takes a minute to get the video.
And then the easy ones is like almost easy.
I never have caffeine. I like save it till
If you don't understand the girls in there,
Okay,
I don't want to.
hey, no one talk, look up. Okay, so this is the reference sheet. You all have that. Okay, the reference sheet talks about inflection point. It talks about relative min, relative max. It talks about relative extrema. And it also talks about critical points. All of those words are defined in this box on the reference sheet. You have to have all of those. You don't have to have those definitions memorized word for word because the test will not have any sort of question where you just have to regurgitate the definition. What the test will have is problems that will check to see if you understand the definition. Honestly, once you understand one of them accurately, learning the others goes very quickly. So I can't remember in this class, have we talked about relative min or max yet? No. Have we talked about inflection point? Okay. So because we talked about inflection point, moving on to the other definitions should go pretty quick. 22 is talking about critical point. It shows you a graph of f prime. It wants to know how many critical values does f have. That's pretty common on the AP test. Show you one graph and ask you questions about a graph you cannot see. So the reference sheet is here to help because it shows you all the graphs. For example, in problem 22, we're trying to figure out where f has a critical point, but we're doing it by looking at f prime. So if I look at the reference sheet for a minute, the definition says that any function, so right now I'm going to think of that as f. So f has a critical point when the slope of that function is either 0 or undefined. So one way to identify where f has a critical point is to look at f. F is the blue. So everyone raise your hand and tell me. F will have a critical point when the slope of f is either 0 or undefined. So raise your hand if you can tell me at what value, these different times, at what x coordinate does f have a critical point? Hands up. At what x coordinate does f have a critical point? You're looking for f has a slope of 0 or a slope that is undefined. Haven't really done a lot with that yet, so really just the slope of 0 right now. So where does the slope of f 0, Cash?
It's the blue line, right?
Yes.
At the origin.
So right here at x equals 0, f absolutely has a slope of 0. If you knew that, 2 points. Anywhere else where f has a critical point? Somewhere else where f has a critical point? There we go. Let's go, Ella.
That 2.
X equal 2. So 2 points, but mistake. Right there, f has a value of 0, but a critical point of f is where f has a slope that is 0. So the slope of f at that moment, again, 2 for Ella, that slope is not 0. So this would not be a critical point of f. Hands up. Where else does f have a critical point? Does that make sense, Ella? Where else does f have a critical point? Let's go, Sarah. Oh, that's fair.
But it's the...
So I'll do this, Sarah. Here we go. This is a good game. You say stop when f has a critical point. Perfect. It's that one right there. It's a little hard to see. How many knew that one? 2 more. Cool. Okay. Those are the 2 critical points of f, where f has a slope of 0. And I have seen AP questions where you'll do exactly what we just did. You'll look at f, and you'll have to find where f has a slope of 0 to identify the critical point on f. What question 22 is doing is different. It's asking you to look at f prime and figure out when f has a critical point. So we're looking at f prime now, And we're supposed to be able to tell from f prime when f will have a critical point. Well, look right here is the best place to look. Just raise your hands. What's the value of f prime at that black dot? Hands up. What's the value of f prime at that black dot? Value means y coordinate. What's the value of f prime at that black dot? Wait for a couple more hands. Most everybody. Let's go, Trevor. 0. So the value of f prime right here is 0. 2 points if you knew that. But f prime's values are the slopes of f. So if all I could see was f prime, I would still know that at x equal 1.250, f would have a critical point. I am looking at f prime, but I am identifying a critical point on f. Questions? Okay, so back to 22. Stop. It's me. Go. It's not what I want. You gotta know what you're looking at. You're looking at that. That was exciting. I don't know how to do that. That's interesting. Okay, whatever. My own voice. We've gotten that one. 22. This is f prime. Okay? This is f prime. You're supposed to look at f prime and figure out where f would have a critical point. Where f would have a critical point. So raise your hand. Tell me the x coordinate where f will have a critical point based on this graph of f prime. About half of you. That's some people going, I don't have a clue. Shaking their head. About half, not too bad. Let's go, Ann.
Like right after 1.
Nice. Right here, the y value right after 1, the y value of f prime is 0. When f prime has a value of 0, that means f has a slope of 0. So at that moment, f will have a critical point. Not f prime, but f. Please.
Could you say that first part again, please?
Yes, I'm going to type it too to emphasize. See if I can find my mouse. Oh, I forgot it here. So, what we just said was this. I'm going to type it, London, for emphasis. We said on the written section of the test, you will have to write something very, very similar to what I'm typing. So you'll write something like this. You'll say, let's see, at x equal, and they don't care that you're perfectly accurate on this. It looks about 1.2 maybe. So at x equal 1.2, f prime of x has a value of 0. Therefore, f of x has a critical point at x equal 1.2. So we have not found a critical point on f prime. We found a critical point of f. But we did use f prime to identify the critical point of f. Questions? Yeah, please, Mike.
So like you're not going to get credit if you just say, oh, well, it crosses the x-axis, the y-axis, and therefore there's a critical point at f of x. You probably want to say, okay, that we know that the slope is, we know that actually no, I guess you could say that. But you don't have to follow it up with f of x has a critical point. You can't just say it crosses the y-axis, and then therefore there's a critical point.
Kind of depends. Let me type it. Hold on. So it's a little hard to tell until we actually type it out, and then I can say, oh yes, that would be valid, that would not be valid. So say exactly what you would write.
Like for the valid version?
Yeah.
Yeah, I guess you kind of wrote what the valid version would be.
I could, but you had an idea, and I want to hear you, say what you were trying to say.
Yeah, which is the f prime
There we go.
crosses the
Hold on a second.
y-axis.
So f prime x-axis.
Yeah.
going.
You can say like at 1.2.
Hold on. Okay, now listen, everybody listen close, listen close. Okay, one thing you do have to get really good at is being very specific. So you did a nice correction. You can't say things like it crosses. That's why there's a big sign up there that says don't say it. And you can't say, it crosses the x-axis. You gotta be very clear. So f prime crosses the x-axis at x equal 1.2. Therefore,
there's a critical point at 1.2, but you have to say f of x.
yes.
Right, so you really do have to clarify that it's f of x. You can't, that needs to be part of the reasoning.
Yes, because you got to make sure the grader understands, Michael, that you are identifying the critical point on f, not on f prime. Because f prime doesn't have a critical point at x equal 1.2. No, that would work. The green statement is just as valid as the purple. Yeah, please, Mary.
So, I guess kind of going along with this, it's probably better to say that like on the purple version, x equals 1.2, f of x equals, or f of x, f prime. That one is 0 instead of like crosses the x-axis?
I like this better, Mary. 2 points for Mary. Here's why I like it better. If I think the crossing thing can cause a mistake, and here's why. If you have an f prime graph, this picture on the reference shows it pretty well. No, that one didn't. Never mind. If you have an f prime graph that just barely touches y equals 0, it's actually not touching here, so that doesn't work. But if it did, like the f prime graph came down and just contacted, but then came back, it never crossed. But if at that moment f prime does equal 0, that will indicate a critical point on f. And so that's why I personally don't like the crossing idea, although what you said in green would be valid, for sure. Please.
Let's say there was like a removable discontinuity, or let's just say there was like a hole at x is equal to 6. Based on the definition of like a critical point, that would be a critical point because it means that the slope is undefined at a given thing.
Two more. Ever hear that? Anywhere f prime is undefined, it's the definition. You look at your reference sheet. Anywhere that f prime is undefined, that is a critical point on f. Anywhere that f prime is undefined, that's a critical point on f. In fact, that has been a bit of a trap on this problem. Look at the board. Because this graph of f prime actually has a vertical asymptote at x equals 0. So at x equals 0, f prime is undefined, meaning f would have a critical point. However, as always, the AP test writers are a bit tricky. They told you don't study x equals 0 because that interval there starts just after x equals 0. So you don't count x equals 0 as a critical point on f for the purposes of this question. This is a very good question. Cool. Let's do a couple of follow-up things. I'm going to go type again. I think that helps clarify when I type it out. Okay, let's finish this one first. So hands up again. Where else does f have any other critical points based on this graph of f prime? Hands up. Does f have any other critical points based on this graph of f prime? Keely?
The point?
So what x coordinate would f have a critical point, Keely?
Like 2.4.
That sounds about right. 2.3 maybe. How many saw that one? Two more. Where else? Keep going. You got the idea now. Where else? Let's go, Cash.
3.8.
About 3.8. 2 points if you saw that one. And then there are no others. It doesn't touch here. So f prime, that would be the only places where f would have critical points. Okay? So let's see, that was how many? 1, 2, 3. So the correct answer is 3. Questions? Yeah, please, Lynn.
Sorry, so you said those are the only places that has critical points, but you also said the critical points is where the slope of the value of f equals 0.
So let me say it back to you. It goes back to this word here. You just have to keep pushing yourself to be ultra precise. don't ever say, everybody look at me. Don't ever say the word critical point unless you follow that word with of. Saying critical point alone doesn't make any sense. So I can say the critical point of f will occur at the same x coordinate where the value of f prime is 0. So right here, f prime has a value that is equal to 0. But the values of f prime are the slopes of f. So if this f prime value is 0, that means that that x coordinate, 1.2, f will have a slope of 0. And the definition says when f has a slope of 0, f has a critical point. That answer. Okay, 2 for Lynn. Oh yeah, please, Trevor.
Is there an easier way to be able to tell if it hits 0 or not? Because like some of them like near like 6 and maybe like 9. It looks like it's like kind of hard to tell.
That's a good question, Trevor. They will not give you an AP test question where you don't have the ability to clearly decide. Like you won't be stuck wondering. That's why there's this big note up here.
Okay.
And the gap at 9 should be big enough that you can see that there's a gap. Does that make sense? Yeah, they won't leave you wondering. It'll be either clear that it is or it isn't. So, good question. Anything else? I want to type a couple more things here, so hang on. While I'm getting ready to type, we're changing the question. I do this all the time. So we're not doing 22 now. We're doing a new question. The question is, I am back here typing where f has critical points. I'm doing that based on f prime. For example, we could expand the purple now and say at x equal 1.2, also x equal, what is it, 2.3, and x equal about 3.6, maybe-ish. If I do something wrong, speak up. F prime is equal to 0. Therefore, f of x has critical points at those x coordinates. Now I want you to raise your hand and tell me, where does f prime have critical points? Where does f prime have critical points? So looking for f prime has critical points. There we go, getting a few hands. Let's make this look better. There we go. And get ready to type. Come on. Just driving the computer from the back of the room is interesting. Hands up, who's got it? Where does f prime have critical points? Go Brig.
1.5.
Let's look at it. So let's say at x equal 1.5. Oh, that's really good, Brig. That's really good. F prime has a slope of 0. Therefore, f prime has a critical point or critical value at x equal 1.5. Raise your hand if you knew that before Briggs said it. 2 more. And there are other, yeah, please.
So at f has a slope of 0, therefore f prime has a critical point. Or is it f prime has a slope of 0, so f prime has a critical point?
Perfect, perfect. So we're looking at f prime. We see that right here, no, that's perfect, Cash, 2 more. We see that f prime has a slope of 0. That means f prime has a critical point at that x. When we did the purple one, our thinking changes. We say, whoa, we're trying to figure out when f has critical points.
Yeah.
We can do that by finding the zeros of f prime.
Okay.
You with me?
Yeah.
Cool, good work. Let's go ahead and make this more complete here. Hands up, where else does f prime have critical points? There we go. Let's go here to Tom.
3, 4.5.
Keep going, Tom. I'll keep typing.
6.
4.5, yeah-ish.
Yeah. 6, 8,
There's a bunch of them.
like 9.5.
Gotcha. Perfect. Awesome. How many saw those? Show me hands. 2 more. Okay, cool. So I'm gonna move this a little bit so we can see it better. The old turnkey. And this would be 3, 4, 5, 6, 8, 9.5. Perfect. Well done. That is really well done. That whole idea of just looking at one graph to figure out what another graph is doing, that's what this part of the reference sheet is all about. Is just looking at one graph to figure out what some other graph is doing. And the test you take on the 16th, probably about half the questions are of this type. About half the questions. Okay, let's stop the video and do the next one. Stop that.